Hi my friends, today we model this part, which is a sheet metal part, and because of its hexagonal shape is called hexagonal housing. The drawing is this. You see the thickness of the sheet metal 0.5, which is by default, as you know. And we start by creating this face with dimensions 50 on 40, but we have to repeat this dimension, so we adopt a special procedure for you to be more informed. Let's start. Sheet metal part, XY face, rectangle, this midpoint on the center point, then dimensions, and now be very careful because I write here side face length equal 50. Home. You see, if you click here and you select expression, you see that dimension. The other is 40, and you know that this was D0 and this is D1. If you take a look at the parameters table, you see the new name here, side face length 50 millimeters, and you see the thickness and a lot of other definitions based on the thickness. Yes, okay, finish sketch, and apply face. Okay, good. Now I apply flange looking from another direction, select this edge, I place here 60 degrees because this is the angle from this face when the shape is hexagonal. And here I select parameters side face length, but eliminating what it was before there. You see, this is the new face, the new flange. I don't use now OK, yes, because I have some other to place here. Apply, another one, apply, another one is this. OK, good. A good start. We have a good start here. Now if you take a look here, you see that this is a pair of new flanges with a cut inside, which must be placed at the 3 millimeters distance between them. To do this, we create another face, but I have to subtract something because this is not the same length with the other. The same length was if I placed here this point. So I go back and I create a new flange with a length of -2 multiplied with thickness CK. Yes, select the face, the edge, and this is the new face. Okay, now I want to place at 3 millimeters divided by 2 from the midplane this new flange with a length of 12. Yes, this is a problem. We have to make some special procedure. So I create a new plane, midplane between two planes, this and this, define this plane, and then I create another plane based on this one to the right at 3 millimeters divided by 2. Okay, now I have an end for the flange. This seems to be a very small distance. I don't like it. Let's see. Flange based on this, not by value. The angle is 16, but we are not interested in, but by reference. Reference to be this plane, and the distance is not side face length minus 2 thickness, but 12. Okay, you see, this is very good. F6, very good. I hide these planes because I don't need them, and we have a good start. I need this plane. This is the mid plane, yes? Good. Why I need it? Because I apply mirror of this and this two faces, two flanges. Mirror plane is this one, mid plane between face and face. Okay, very nice, very, very nice. What next? Next is another flange. What flange? This one with 30 millimeters, but with miters on the sides. Oh, no problem. Look at my ability here. I select not by reference but by value, not 60 but 90, not 12 but 30, and the edge. The edge is the internal one, which is rectangular, of course, but when I select the next one, it is miter between the two, and then other and another, and the last one. Okay. What you say, my friends? Very nice, professore. Very nice. Good. The problem here is with this distance, which I don't like. It is not in the model because there is a cut here. We have to change something. Yes. What to change? We change this flange. Double click, and now we take advantage of the fact that Inventor is a parametric software, isn't it? So I can edit everything, not like in AutoCAD, where you place a dimension and it is a result, not a cause, that dimension. What to do here? Well, I select this more option. I select width. We know this procedure from my previous tutorials. I don't have here what I need, so I stop this moment and I go to the parameters table. I take a look at this dimension and I change its name. Its name is, for instance, height. Yes. I could use D2, of course, but I like to have a name here for you to understand better what I want to present here. Again, we edit this flange and we select more, width, offset. This must be not 10 but height minus 2 thicknesses. I can select thickness from here. 2 multiplied by list parameter and I select thickness. Oh, excuse me, I was wrong. Not side space face, but thickness. Good. Now I eliminate this 5 and I select an edge. I want to be measured from here but in the other direction, and this is a little under the other. Yes, with what value? The value of twice thickness. The distance between these two is 2 thicknesses. Yes. Okay, when I end this, the mirrored features will be modified as well. Okay, you see here that cut? Yes. Good. Let's finish with this. We finish because we have dimensions. You see a slot here, yes, 28, 5, 2.2, and centered on the vertical. Yes? Good. This is the face for that new sketch. Not rectangle, but center point slot. Center is here, direction is this, radius is this, and we place dimension. This is 28. You see, 28, it was 5, 2.2, and don't forget, my friends, that these 2 points are on the same horizontal. Now it's fully constrained, this sketch. We are very careful to have always here fully constrained. I forgot sometimes in the past, but you forgive me, I'm sure of this. Now, cut. I use cut for this, not on this distance, but through all. Okay. And you see, this is okay. It has also a corner round here of 1 millimeter. Corner round, 1, 2, 3, 4 of 1, not 6. Okay. Now there are some other slots distributed around this hexagon. Dimension is here, again centered on the face, 28, radius 1. I select this face, I draw the slot, center, distance, radius. I make it especially great to be sure that I don't forget something. This is 1. This is 20. You see, by homotety, it goes to here when you apply the first dimension. 20. Same vertical, this point with the center point or the midpoint up, and the distance of 8 between these two, 8 millimeters. But I want to eliminate expression, presentation instead of value. I don't like it. This is 20. Finished sketch. Fully constrained? Yes, sir, fully constrained. Good. Cut. What to cut? This. On the depth of the thickness, not through all. Okay. Why? Because now I apply circular pattern about an axis. Where is the axis? Because it is not the axis Y. Yes? Axis Y is here. This was the center point. This is X, Y, and Z. So I create a new sketch. I project this edge. I place here a line between midpoints. I place also a point in the middle of this new line, and now I use axis in two steps. One is create point, and I place here that point, and second is select a plane to be perpendicular, the new axis on it. I make not visible the sketch, the axis is present, and I apply circular pattern of what? Of this slot. About what? About this axis. How many items? 6 by default. Okay. F6. I hide the axis and I apply material which is steel carbon or steel milled, and the presentation of steel polished. Now we have finished our part. Good for us. Let's see what about the volume. The volume is right here. Update. Let me copy, close, drawing, home, click, double click here, and paste. Bravo! Exactly the same. I'm very happy for this. Cancel, and this is the best part finished. You have to take care here with that dimension, but the rest is with some tricky moments, of course, like anything in your life, my friends. That's all for today. Thanks for watching. Bye bye.